Hello friends. Today we're going to solve generate parenthesis problem. Let's see the problem statement. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So given n, so n equal to some integer, so which means that these many number of pairs is given to us. So we have to form a well-formed parenthesis combinations out of all these pairs. Okay. So since this is a combination problem, so we have to generate combinations by making selection of paths, right? So we have some start initial state and we have some end state. So in order to reach end state, we have to travel by various paths, having tracking the various combinations, and we reach the end state. So let's see how we travel, how we generate all the combinations by making some selection. Once we make a selection, so and we are moving ahead with one selection to reach the end, and also we have to backtrack to the initial state where we have started and take another decision, which may also lead to the end state. So, for example, if we start with an empty string, that is our initial state, and we have to reach any well-formed, you know, parenthesis string. So this is our end state. We have to reach from empty string to the well-formed parenthesis state. So we have some options from empty string. We can either select one open parenthesis or a closed parenthesis. So you know that in combination problems, this selection will also lead to a well-formed parenthesis or some combination of parentheses, which we can make sure that it is well-formed or not in this problem. So, but if we make this selection, it also lead to some combinations of parentheses, which we have the list of pairs already available with us. So, likewise, if we select this path, which also leads to well-formed or non-well-formed parentheses state. Let's see in detail. In this example, I have taken n equal to 2, which means two open parentheses and two closed parentheses. So we have to make a selection, okay, from initial state. So our initial state is, we are tracking the number of parentheses already consumed. That is, how many number of open parentheses already taken, how many number of closed parentheses already taken. And the initial state is 0 and 0, so we haven't taken any open parentheses or closed parentheses, and we have the empty string. Okay, so eventually we have to reach the end state, which is the maximum. We have already taken two open parentheses and two closed parentheses, and we have to make sure that it is well formed parentheses. So this is our end state, and we have multiple paths to reach that. Okay, let's see in detail how we make selection and then we reach the end state like that. So from the initial state, we'll be selecting one open parenthesis, and also we are selecting one closed parenthesis. You can just see without open parenthesis, we cannot, you know, have a closed parenthesis. This path may lead to a non-well-formed parenthesis string. This branch can also lead to a combination, of course, but this will not guarantee that this is well formed. So we are not going to proceed with this. So let's ignore this part and we take this decision. So from this is our next state. So we can just take decisions from this state. So we again select one open parenthesis. From this state, we can also take one closed parenthesis, which is valid because see we have already having one open parenthesis. So if you closely notice that we have a condition that we can proceed with this decision or not, that is, we have to have enough open parentheses already in our list in order to proceed to take one closed parenthesis. You know, so the open parentheses already we have should be greater than the close parenthesis. If that is the case, then only we can proceed to take one close parenthesis, right? So in this scenario, this decision is very much valid. This path is very much valid. So let's go ahead with this. So we cannot go and pick up one more open parenthesis from here because we have already reached the maximum. We can take one close parenthesis because we have two remaining close parentheses. Also, we cannot take one more open parenthesis from this state, and we can just take one close parenthesis. So we can see that this is the end state we have already reached. So no more open parenthesis and no more close parenthesis. So this is the end state. So also you can see that This is the well-formed parenthesis combination we have formed. So this can be an answer to our list. Okay, we have actually reached the end state and we have to backtrack to this state. And from this state, we can actually take decisions to take one remaining open parenthesis and one remaining close parenthesis. Okay, we have taken the remaining one open parenthesis and there are no more open parentheses left from this state. We can just take the remaining one close parenthesis. So this is one more end state we have reached, and also we have the well-formed parenthesis. So you can see that we can eliminate a branch by using a condition that we cannot select a close parenthesis without having enough open parentheses, right? That is, number of open parentheses must be greater than the close parenthesis still now selected. Okay, so by this condition, we can just eliminate this branch, which we ensure that there is no non-well-formed parenthesis combination. Okay, so continuing from this state, there is still one more close parenthesis we can just take, but as I already mentioned, there is no enough open parenthesis, so we cannot proceed to take one more close parenthesis. So this branch is eliminated. So as you can see, these are the end conditions, and we have already met, and we have the well-formed parenthesis generated. Okay, so whenever we reach this end state, we can just push the string to our answers list. Okay, so hope it's clear, and let's code this. So I'll remove this. So we have an answers list. We have to return that. And what we are going to do is we can just design a recursive function which starts from initial state and we go deeper and hit the end state. Let's call it as generate, which accepts number of open parentheses, number of close parentheses, and uh, the string. We'll keep track of the string along the path which we generate. Okay, so we can just write the end state condition here. If open, uh, reached the maximum, that is n, and close has reached the n, then just push that answer. Okay, answer to push string and just return. Okay, if some open parentheses left, okay, then we can go ahead and pick up that, right? So generate, pick one open parenthesis, okay, with the current close parenthesis status, and then just append one open parenthesis, right? As we are going to select. So, and we can just repeat the same condition here, like just if there are enough close parentheses, we can also select uh, with the current open close plus one string plus close. Okay, see, we can just take this decision, but for example, if we are in the initial state, you know number of open parentheses is actually 0, right? So without having any open parentheses, we cannot have, we cannot take a close parenthesis, right? So we can have one condition that uh, uh, there should be enough open parentheses than the close parentheses. Okay, so if this is a condition, then we can go ahead and pick up one close parenthesis and add it to a string. Okay, so these two decisions. So this is one path which will lead to this end condition, and this is another path which will also lead to this end condition. Okay, so let's call this generate. Initially, number of open parentheses 0 and number of close parentheses 0, and we have our empty string. Okay, so let's go ahead and test this. All right, it works. So this condition will actually, avoid the non-well-formed tree generation in our recursion tree. So let's go ahead and submit this. Works. So hope you enjoyed this video and thanks for watching.